Lesson 107, maximizing area. So if you have a figure whose perimeter remains the same, and we want so you have the perimeter and you want the biggest area possible that you can get out of it. Okay, so here's an example. The perimeter remains the same. And we're going to make it at 24 units. Find the area when the base equals 2, the base equals 4, the base equals 6, and the base equals 8. So if the perimeter is 24 and the base is 2, then the height has to be 10.
Okay.
That way the perimeter will be 24, 10 plus 10 plus 2 plus 2, and we can find the area by just taking 10 times 2. But first we're going to say 24 equals, so we have 2 times the base plus 2 times the height, and that's how we find the height. So we'd subtract 4, we get 20, divided by 2, the height then is 10, and the area equals base times height. So the base is 2, the height is 10, the area would be 20. Now what if the base is 4? So we have our perimeter. You do 2 times 4 plus 2 times h to find h. So you take 24, subtract 8, you get 16, divided by 2, then h is 8. So the area, base times height, is 4 times 8, or 32. Then when the base is 6, we do 2 times 6 plus 2 times the height. So we take 24 minus 12 to get 12, divided by 2, then the height would be 6 also. The area would be 36. And then if the base is 8, the perimeter is 24, so we do 2 times 8 plus 2 times the height to get 24. 24 minus 16 is 8, divided by 2 is 4, so then the height would be 4, and the area would be 32. So to maximize the area, we would have to have a square where the base and the height were both 6. And that would give us the maximum area. Notice that it starts going up and then it starts coming back down. Now we're going to have 4 different polygons, and all of them will have the same perimeter. And we want to see which one will give us the maximum area. So we'll start with an equilateral triangle. Since the perimeter is 30, we know each of the sides will be 10. And the area will be half the apothem times the perimeter. Okay, so we do 1/2 of 30, and then we have to find the apothem, which was, is it 5 root 3? Okay, wait, this is, wait, say that again. It is? Okay. I'm not sure. I can't remember. So we want this one. This is 5. Oh. Wouldn't it be 5 root 3 over 3? I think it's 5. Okay. And then let me just double check the math, because I know what the area is. So 15, 5 divided by 3 times the square root of 3, 43.3. Okay, so it's approximately 43.3. Then we're going to do a square. The perimeter's 30, so you divide 30 by 4, you get 7.5. Square that. The area is approximately 56.25. And then if we do a pentagon, well, it's supposed to be regular. So we divide 30 by 5. Each side is 6. The apothem is 4. How do you know? So that, say what?
It says right here in the book.
Oh, there we go. That's how, okay. Find the area, so half the perimeter times 4.13, which is approximately 61.95. Then we're going to do a 1, 2, 3 hexagon with a perimeter of 30. So that means one side is 5. The apothem is 5 root 3 over 2. So the area will be approximately 64.95. Notice that as we increase the side, the number of sides, keep the same perimeter, the area is getting bigger. So the closer we get, well, the regular polygons have the greatest area with the given perimeter, and the more sides that we have gives you more area. So the greatest area, so the more sides we have, more, what figure are we getting close to?
Circle.
A circle. So a circle would actually have the maximum area with the given perimeter. So there's a couple of things. For a given polygon, a regular polygon has a greater area than an irregular one. So if you're talking about like a pentagon, if all the sides are the same, you're going to have a greater area than if you have different length sides. For a given perimeter,
What if the sides are like super big?
as long as if you keep the perimeter the same, if you rearrange all the sides, like find the average and then give them all the same length, you'll have a bigger area. Yeah, you could draw a picture while I'm writing this down, which means then you'll have to catch up after notes.
So it's like you've got a pentagon. That's really a pentagon. Yeah, but then it's got the same side lengths. But one will have a double. That does not say anything as that. This is bigger.
Mm-hmm. So if you're given a perimeter, a regular polygon with the greatest number of sides has the greatest area with that perimeter, which is what we said here. And that's the end of the lesson.